Okay, here we go. Algebra 2, Chapter 5, review. If you look at the first three questions in the review are making sure that you know properties of exponents. So remember, if you have like bases and you're multiplying those like bases, you're going to add the exponents. If you see something where you have a power to a power, you would multiply the exponents. Okay, so with this one, a couple ways you could do it. Some of you that I helped with, you want to take the power to a power first. If you do that, just make sure you take 5/4 times negative 1/4. And here you would take negative 3/2 times negative 1/4. Use your calculator. I probably would take and put these together first so that I only have to do the multiplication once. So again, I want to keep my base of 7. I want to add those exponents. So don't be afraid to use your calculators. Some of you are trying to do this without your calculator. Take 5 divided by 4 plus negative 3 divided by 2. I'm just adding the exponents. And I don't really want to leave it as a decimal, so remember you hit the math button. So when you hit that math button, you go to convert to fraction. Negative 1/4. So when I add these two together, I get 7 to the negative 1/4 power. But remember, that's all still raised to the negative 1/4. So when I added these exponents, I get 7 to the negative 1/4. I have this power raised to a power, so now I need to multiply. So again, on your calculators, take negative 1/4 times negative 1/4. When you do that, you should get 1/16. And that's your answer. Number 2, I just put on there to show you that even if there's coefficients in front, you still want to multiply negative 3 times 2, negative 6. When you have x to the 1/5 times x to the 3/5, you keep the base. You're multiplying, so you add the exponents, and you should get 4/5. So just multiply the coefficients out in front, and then when you're multiplying like bases, add the exponents. And 3, it's a little bit trick of making sure you know what that negative means. Remember, a negative out here means negative 1. Just like if there wasn't a coefficient there, we think of it as a 1. So realize that's a base. So you need to take negative 1 squared. Negative 1 squared is positive 1. Then you have to take m to the 2/7 and square it. So again, you multiply the exponents, you get m to the 4/7. Use your calculator. Really, when you're multiplying, just realize you're multiplying straight across. So that's why I got 4 in the numerator, but 7 times 1 gave me 7 in the denominator. And then the n base, I keep the base of n. I multiply negative 1/2 times 2 is negative 1. And then the only other thing you have to realize is make sure you know that that means that that base has to get flipped down to the denominator. So I have a 1. You can write the 1 if you want. You don't have to. M to the 4/7 over n to the first. And again, you don't need the 1 there, but that's what we did. We took this n to the negative first, and we brought the whole base down to the denominator. Okay, so of those 3, I would definitely take a look at number 1. Make sure you know how to do 1. All right, 4 through 6. These are radicals that you need to simplify. So with these, I don't want you to put them in exponential form. I want you to simplify them. So what you need to do is you need to look at, first of all, what roots you're doing. I have a square root, a cubed root, and a 4th root. So you have an example of each. So it's a square root. So now I'm thinking of perfect squares. So if you aren't sure what the perfect squares are, write them down. 2 squared is 4, 2 times 2. 3 times 3, 4 times 4, 5 times 5. You could keep writing them down, but when I got to 25, I realized that goes into 75. So I'm going to write a nice long square root, and I'm going to say 75. To do 75, I'm going to break it up into 25 times 3. That gives me 75, and 25 is a perfect square. X to the 7th. To be a perfect square root, this has to be an even, has to be divisible by 2, an even power. So I'm going to break that up into x to the 6th and x to the 1st. Y to the 8th already is a perfect square root, so I'm going to leave it alone. So all I did is I rewrote these numbers. 75 I wrote as 25 times 3. X to the 7th I wrote as x to the 6th times x. And y to the 8th was okay. So this is a perfect square I can simplify. This is a perfect square. and so is this. So the ones I have circled, I'm going to simplify. Square root of 25 is 5. Square root of x to the 6. So if I go x to the 6 over 2, because remember my root is 2, I get x squared. Y to the 8 over 2 gives me y to the 4th. So that's the square root of 25, x to the 6th, and y to the 8th. What's left has to stay under the square root. I have a 3 and I have an x. Okay, let's do the cubed root one. Cubed root, now we're thinking of perfect cubes, so if you need to write them down, 2 to the 3rd, 2 times 2 times 2 is 8. And already I see that's the one I want. If you want to complete your, keep going with your list, 3 to the 3rd, 4 to the 3rd, they get big really, really fast. Those are the perfect cubes, 2 to the 3rd, 3 to the 3rd, 4 to the 3rd. So I want the 8. So again, I'm going to write one big long cubed root. 16 I'm going to write as 8 times 2. Now to be a perfect cube, the exponent has to be divisible by 3, because now that's my root. So the a to the 16th, I'm going to write as a to the 15th times a to the 1st. B to the 5th, I'm going to write as b to the 3rd and a b squared. And a c squared I can't take anything out of, so I have to leave it as c squared. So again, I broke up 16 into 8 times 2 because I can simplify 8. A to the 16th, a to the 15th times a. B to the 5th is b to the 3rd times b squared, and then the c squared has to still be there. I can't take anything out of there. So when I do simplify those circled, I get 2a to the 5th, b to the 1st. What's left under the cubed root is a 2, an a b squared, and a c squared. So again, when you're finding the cubed roots of these powers, remember, think of it as putting it into exponential form. A to the 15 thirds. 15 divided by 3 is 5. That's why it simplifies to a to the 5th. B to the 3rd, 3 divided by 3 is 1. So that's why I got b to the 1st. Okay? And then let me do the last one. I think 81 is a perfect 4, so if I'm going to try, and again, if you aren't sure, use your calculator. 3 raised to the 4th. It is a perfect 81 is a perfect 4th. So I'm going to leave, again, draw the 4th root of. 4th root of 81 is 3, so that already is a perfect 4th. M to the 5th is going to be m to the 4th and m to the 1st. N to the 15th, I'm going to do n to the 12th and n to the 3rd. And p to the 8th is a perfect 4th. So now we're thinking of 4th roots, so the things that I can simplify, the exponents have to be powers of, or multiples, I should say, of 4. So 4th root of 81 we said was 3, so I can simplify that. M to the 4 over 4 would be m to the 1st. N to the 12 over 4 would be n to the 3rd. P to the 8 over 4 would be p squared. What's under the 4th root would be an m and an n to the 3rd. So there is one question like that on the test. I think I'll stop there, and then I'll try to get the 7 through 12 on the next video.